1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 plus 1 over 1 plus 2 plus 3 plus 4 and so on is what. So first we should focus on the denominator. Here the first denominator we can say is 1, the next one 1 plus 2, 1 plus 2 plus 3. For solving this, we should know that 1 plus 2 plus 3 plus 4 n is what? If you don't know it is what, it's not hard. I will tell you how to solve. We say, let me write place that have more space. N minus 2 plus n minus 1 plus n. Then I write a in reverse order. N plus n minus 1 plus n minus 2 up to 3, 2, 1. Now, if we add these two equations, let's see we will reach. Left hand side is 2a, right hand side 1 plus n, n plus 1. This column 2 plus n minus 1, n plus 3 times n minus 2 is n plus 1, up to n plus 1, n plus 1, n plus 1. We call this method that is so much useful, also useful in IMO, Gauss idea. Okay, so let's work on that. How many n plus 1 are there? N times n plus 1. If we divide both sides by 2, let's see we can reach to what number. We can see that a equals n times n plus 1 over. Now, as you can see, the denominators that we have, uh, as you can see in the denominators, we have 1 and we can write it like this. So, if we consider these fractions, let's write 1 over 1, 1 over 1 plus 2, plus 1 over 1 plus 2 plus 3, 1 over 1 plus 2 plus 3 plus 4, and so on. If we want to write 1 plus 2, n is said is equal, we proved in previous page that it is n times n plus 1 over 2, so 1 over 1, n is 1. 1, 2 over 2, we write all of them, same form. 1 plus 2 is 2 times 3 over. Next one is 1 over 3 times 4 over. Next, 1 over 4 times 5 over, and so on. The next, we calculate this, it will be equal to, for each of them, we multiply both numerator and denominator by 2 over this, 2 over 2 times 3, plus next one will be the next one plus 2 times 3 over 4. Next, 2 times 4, 2 over 4 times 3, and we factor from 2. And it will be what? 1 over 1 times plus 1 over times 3 plus 1 over 3 times 4 plus 1 over 4 times 5 and so on is equal. Now, in this step, if you want to calculate this, look, let's calculate 1 over 1 times. You want to use telescoping rule. If you don't know, you will see the rest of it. This what fraction minus what fraction, right? You can see it is 1 over 1 minus 1 over 2. Okay? Use one denominator, 1 minus. And in general, you can say 1 over k times k plus 1 is equal to what fraction minus 1? Is 1 over k minus 1 over k. Then if you write this part, it will be 1. First part, what? 1 over 1 minus 1 over next part. We apply this. 1 over 2 minus 1 over this. 1 over 3 minus 1 over. And the next part, 1 over 4 minus 1 over. so on. So let's see which terms will be cancelled. Consider the term. These two terms will be cancelled, these, and so on. One thing you say, okay, this term that f minus 1 over 5, the next time 1 over 6, tends to 0 because the denominator is increasing, so it will be also, so the answer is 2. But if you want to write, for example, in a little more professional way, you can say, oh, equal to 2 time limit, or for example, b approaches infinity, 1 minus 1 over b. Then you say, oh, equal to 1 equal. You can write it also in this form. And we call this action that terms like this are eliminating telescoping rule, or here telescoping. We have also telescoping product. Telescoping rule is useful in AMC, American Mathematics Company, BMO, British Mathematical Company, Olympiad, in AIME, IMO, US AMO. For example, in IMO, in one part of the problem, you need to use telescoping rule. For example, in function problems. If you want to learn all those ideas, send message to my WhatsApp number, and please don't forget to subscribe, turn on the bell, and like. Thanks. Bye.